example 7. Still, we are solving, okay, and graphing the solution of an inequality. So the inequality we have here is a 3x over 10 plus 1 greater than or equals to 1/5 minus x over 10. And so once again, what I have here, lots of fractions. That's what I noticed. I have lots of fractions. And this time, the worst thing is happening. We have all different denominators. Here I have this first fraction here, 3x over 10, denominator 10. The next one over here is 1. You can think of that as 1 over 1. And here I have a 1 over 5, denominator 5. And here's back to another one, denominator of 10. So we need to find a way to clear fraction away. And the only way to clear fraction away is to find the LCD for all these different denominators. So here I have denominator 10, denominator 1, denominator 5, and denominator 10. So my LCD in this case is going to be a 10. That's my LCD, least common denominator. And now once I've found my 10 as my LCD, what I need to do is multiply that 10 to both sides of the inequality, meaning the 10 is going to be multiplied to each term throughout the two sides of the inequality. So what I have here is on my first term, I'm going to go 10 times 3x over 10 plus 10 times 1 greater than or equals to 10 times 1 over 5 minus 10 times x over 10. So the 10 here, the LCD that I just found, I'm going to just simply multiply that to both sides of the inequality. And once again, notice one more time, since the LCD that we found was a positive number, so multiplying it to both sides of the inequality does not change, does not reverse my inequality. So, on the first term, the 10 cancels with the 10. On the second term, that all becomes a 10. So, on the left-hand side, I'm going to yield 3x plus 10 greater than or equals to. Now, on the right-hand side, if you focus on the first group right here, on the first term right here, 10 times 1 over 5, 10 cancel with the 5 gives me a remaining factor of 2. So I have 2 times 1, that gives me 2. Now 10 here cancel with the 10, gives me the x remaining. So here I turn into 3x plus 10 greater than or equals to 2 minus x. So now my last step to solve the inequality, I need to subtract 10 from both sides and add x to both sides. And that gives me 4x greater than or equals to negative 8. And so the last step to solve for x here would be just simply dividing both sides by 4. And my x would be x greater than my possible values of x satisfying the inequality. It would be x greater than or equals to negative 2. So that's my logical solutions. Now, so graphing this solution right here, once again, draw for yourself the line of number. Negative 2 can be anywhere on the line, and I choose that to be a little, near to the left hand of that line. But then I want to shade to the right hand side of negative 2, since the final inequality is saying x is greater than or equals negative 2. And also, since the inequality involves the equal signs, means we do include negative 2 as part of the possible solutions. So now I am going to put brackets, square brackets on negative 2. And then finally expressing the inequalities, the solution of the inequality in interval notations. All I do is just negative 2, comma, positive infinity. That's how I write the final answer in interval notation. Interval notation. Okay? Okay, so one last example for all these inequalities, solving linear inequalities here. So example number 8. We would like to solve again, solve and graph. We would like to solve and graph the inequality. So what I have here is 4x minus 3 over 8 plus 2 greater than or equals to 2x 4x minus 1 over 12. Okay, so once again, here's the worst nightmare ever. Now, once again, we have just fractions all over, and we have all different denominators. So, once again, we look our way up. We need to find our way to clear all the fractions away. And the only way of clearing the fractions away is to find the LCD. Now, the LCDs I can find in this for this problem here. I have denominator 8, I have denominator 1, I have denominator 12. So my LCD here, the best LCD, the LCD here is going to be 24. And once again, if you're surprised how I found 24 to be the LCD, make sure you check out my other videos for learning how to find the LCD here. But by the way, once you found the LCD, you need to multiply the LCD to both sides of the inequality, and technically that would distribute to every single term. So basically, you need to multiply the LCD for every single term throughout the two sides of the inequality. So my first term, which is that huge fraction there, 4x minus 3 over 8, I'm going to multiply that to 24. The next term on the left hand side, 2, I need to multiply that by 24. And then the next term on the right hand side, 2x minus 1 over 12, I also need to multiply that by 24. Okay? So now the whole purpose of multiplying the 24 throughout all the terms on the two-hand sides is because I want to clear the denominators away. So on the first term here, 24 cancel with 8s. Cancel 8 away, and 24 has a 3 remains. 4 as factor, so I have 3 times 4x minus 3 remains for my first term. Plus, now 24 times 2 is 48. Greater than or equals to 24 cancel, 12 cancel into 24, and there's a 2 left. So we have 2 times 2x minus 1. So now here I turn into a different inequality. At this point, the good thing is we're completely out of denominators. We are completely out of fractions. We clear all the fractions away. And so I'm going to multiply. We need to apply the little distributive law to both sides here. And what I have is a 3 times 4x. That gives me 12x minus 9 plus 48 greater than or equals to 4x minus 2. And so on the left hand side, combining like terms, I have 12x plus 39 greater than or equals to 4x minus 2. Okay? And then to solve for x, once again, I need to divide both sides by, I need to subtract both sides by 4x. Okay, and subtract 39 away from both sides. Okay, here's my solution. It turns out to be 8x greater than or equals to minus 41. So to solve for x, dividing both sides by 8, get me x greater than or equals to negative 41 over 8. And once again, you do not have to worry about turning negative 41 over 8 into a decimal point values. That's the point here. We need to learn how to work with fractions. Okay, so that's my logical solution. The graph for that, to graph that solution, once again, negative 41 over 8. It can be anywhere on the line, but here, this is where I choose it to be. Okay, and then the final inequality indicating that we want x greater than or equals to negative 41 over 8. So it's going to be all shaded to the right hand side and also including negative 41 over 8. So I am using square brackets on negative 41 over 8. So finally, the last step here is to re-express the whole solution here in terms of interval notations. So I have negative 41 over 8, common positive infinity. And here's brackets on the left side and parentheses on the right hand side. That's how we finish with that.